Setting up a slave database server. Earlier in this chapter, we discussed installing MariaDB on a server. To set up a slave, all you really need to begin the process is set up another database server. If you've already set up 2 database servers, you're ready to begin. If not, feel free to spin up another VM and follow the process from earlier in this chapter that covered installing MariaDB. Go ahead and set up another server if you haven't already done so. Of your 2 servers, one should be designated as the master and the other the slave, so make a note of the IP addresses for each. To begin, we'll first start working on the master. We'll need to edit the /etc/mysql/confd/mysql.cnf file. Currently, the file contains just the following line. Copy mysql. Right underneath that, add a blank line and then the following code. Copy mysql dlog bin log do db equals mysampled server id equals 1. With this configuration, we're first enabling bin logging, which is required for a master/slave server to function properly. These binary logs record changes made to a database, which will then be transferred to a slave. Another configuration file that we'll need to edit is /etc/mysql/mariad.confd/50server.cnf. In this file, we have the following line. Copy bind address equals 127.0.0.1. With this default setting, the MySQL daemon is only listening for connections on localhost 127.0.0.1, which is a problem since we'll need to connect to it from another machine, the slave. Change this line to the following. Copy bind address equals 0.0.0.0. Next, we'll need to access the MariaDB shell on the master and execute the following commands. Copy grant replication slave on to replicate at 192.168.1.204 identified by slave password. Here, we're creating a replication user named replicate and allowing it to connect to our primary server from the IP address 192.168.1.204. Be sure to change that IP to match the IP of your slave, but you can also use a hostname identifier such as %.midomain if you have a domain configured, which is equivalent to allowing any hostname that ends with .midomain. Also, we're setting the password for this user to slave password, so feel free to customize that as well to fit your password requirements. Be sure to make a note of the password. We should now restart the MariaDB daemon so that the changes we've made to the mysql.cnf file take effect. Copy sudo systemctl restart MariaDB. Next, we'll set up the slave server. But before we do that, there's a consideration to make now that will possibly make the process easier on us. In a production environment, it's very possible that data is still being written to the master server. The process of setting up a slave is much easier if we don't have to worry about the master database changing while we set up the slave. The following command, when executed within the MariaDB shell, will lock the database and prevent additional changes. Copy flush tables with read lock. Note: if you're absolutely sure that no data is going to be written to the master, you can disregard that step. Next, we should utilize miscldump to make both the master and the slave contain the same data before we start synchronizing them. The process is smoother if we begin with them already synchronized, rather than trying to mirror the databases later. Using miscldump as we did in the previous section, create a dump of the master server's database and then import that dump into the slave. The easiest way to transfer the dump file is to use rsync or scp. Then, on the slave, use MariaDB to import the file. The command to back up the database on the master becomes the following. Copy miscldump uadmin p databases mysampled.sql. After transferring the mysampled.sql file to the slave, you can import the backup into the slave server. Copy Myriad root p mysampled.sql. Back on the slave, we'll need to edit the /etc/mysql/confd/mysql.cnf and then place the following code at the end. Make sure to add a blank line after mysql. Copy. mysqld server ID equals 2. Note: although it's outside the scope of this book, you can set up multiple slaves. If you do, each will need a unique server ID. Make sure you restart the Myriad unit on the slave before continuing. Copy. Sudo systemcll restart Myriad. From the root MariaDB shell on your slave, enter the following command. Change the IP address in the command accordingly. Copy. Change master to master_host equals 192.168.1.184, master_user equals replicate, master_password equals slave password. Now that we're finished configuring the synchronization, we can unlock the masters tables. On the master server, execute the following command within the MariaDB shell. Copy. Unlock tables. Now, we can check the status of the slave to see whether or not it is running. Within the slave's MariaDB shell, execute the following command. Copy. Show slave status. Note: here, we're adding G, which changes the output to be displayed vertically instead of horizontally. Assuming all went well, we should see the following line in the output. Copy. Slave_io_state, waiting for master to send event. If the slave isn't running, slave_io_state is blank, execute the following command. Copy. Start slave. Next, check the status of the slave again to verify. Copy. Show slave status. From this point forward, any data you add to your database on the master should be replicated to the slave. To test, add a new record to the employees table on the mysampled database on the master server. Copy. Use mysampled, insert into employees values, Optimus Prime, 100, transformer. On the slave, check the same database and table for the new value to appear. It may take a second or two. Copy. Use mysampled, select asterisk from employees. If you see any errors in the slave_io_state line when you run show slave status, or your databases aren't synchronizing properly, here are a few things you can try. First, make sure that the database master is listening for connections on 0.0.0.0 port 3306. To test, run this variation of the netstat command to see which port the Myriad process is listening on. It's listed as mysqld. Copy. Sudo netstat tilde grep mysql. The output should be similar to the following. Copy. TCP 000.0.0.03306.0.0.0 asterisk listen 946/mysqld. If you see that the service is listening on 127.0.0.13306 instead, that means it's only accepting connections from localhost. Earlier in this section, I mentioned changing the bind address in the /etc/mysql/myriad.confd/50server.cnf file. Make sure you've already done that and restart Myriad. During my tests, I've actually had one situation where the Myriad service became locked after I made this change, and attempting to restart the process did nothing. I ended up having to reboot the entire server, which is not typically something you'd have to do. Once the server came back up, it was listening for connections from the network. If you receive errors on the slave when you run show slave status, with regards to authentication, make sure you've run flush privileges on the master. Even if you have, run it again to be sure. Also, double check that you're synchronizing with the correct username, IP address, and password. For your convenience, here's the command we ran on the master to grant replication permissions. Copy. Grant replication slave on to replicate at 192.168.1.204 identified by slave password, flush privileges. Here's the command that we ran on the slave. Copy. Change master to master underscore host equals 192.168.1.184, master underscore user equals replicate, master underscore password equals slave password. Finally, make sure that your master database and the slave database both contain the same databases and tables. The master won't be able to update a database on the slave if it doesn't exist there. Flip back to my example usage on miscldump if you need a refresher. You should only need to use miscldump and import the database onto the slave once, since after you get the replication going, any changes made to the database on the master should follow over to the slave. If you have any difficulty with the miscldump command, you can manually create the mysampleb and the employees table on the slave, which is really all it needs for synchronization to start. Synchronization should then begin within a minute, but you can execute stop slave, followed by start slave, on the slave server to force it to try to synchronize again without waiting. And that should be all there is to it. At this point, you should have fully stop slave, followed by start slave, on the slave server to force it to try to synchronize again without waiting. And that should be all there is to it. At this point, you should have fully functional master and slave servers at your disposal. To get additional practice, try adding additional databases, tables, users, and insert new rows into your databases. It's worth mentioning that the users we've created here will not be synced to the slave, so you can use the commands we've used earlier in this chapter to create users on the slave server if you wish for them to be present there.